We all know Stephen Hawking was a brilliant scientist, and his legacy lives on in astronomy and research. One of Hawking's theory, the black hole theory, is said to be validated by the James Webb Space Telescope. What is Hawking's theory of black holes? What makes it so divisive? What effect does it have on you? The powerful James Webb Space Telescope may ultimately prove Stephen Hawking's black hole theory. Hello everybody, welcome back to our channel. In today's video, we'll discuss Stephen Hawking's proven right multiverse theory. All credit goes to the James Webb Space Telescope. But before we get into more details, subscribe to our channel and hit the bell icon to never miss a video from us. Now without further ado, let's get started. From their formations to their properties, black holes have captivated scientists and astronomers all around the world. So how do black holes function? A black hole is a region of space in which gravity is so strong that light cannot escape. Black holes have tremendous gravity because matter is compacted into a small space. Most telescopes cannot function because no light can escape. Specific sensors on space telescopes, on the other hand, can aid in the discovery of black holes by observing the behavior of materials and stars in their area. Black holes comes in a variety of sizes, but there are three fundamental types. They are classified according to their mass and size. The smallest are primordial black holes. According to scientists, this type of black hole is the size of an atom yet weighs a mountain. The majority of medium-sized black holes are referred to as stellar. A stellar black hole can have mass of up to 20 times of a sun and can fit inside a ball 10 miles in diameter. There are dozens of star-mass black holes in the Milky Way galaxy. On the other hand, there are the supermassive black holes, which are the largest known to exist. This type has a total mass of over 1 million suns and would fit inside the solar system's sizing ball. A supermassive black hole exists within every large galaxy. The galaxy's supermassive black hole is known as Sagittarius A. It weighs as much as 4 million suns and fits inside a ball the size of a sun. What is the purpose of black hole? Primordial black hole, on the other hand, forms soon after the Big Bang. However, stellar black holes form when the center of a massive star collapses. This collapse results in a supernova, a stellar explosion which ejects matter into space. The supermassive black holes, according to scientists, form alongside the galaxy. The size of the supermassive black hole is proportional to the mass of the galaxy. What happens in a black hole? This is unlikely to happen because the nearest black hole to us is so far away. New black holes appears on a daily basis. However, the nearest one to us is 1,500 light years away. The Unicorn is a constellation in the Monoceros constellation. If you get close enough to a black hole, it will suck you in and rip you apart since no substance, especially squishy human bodies, can survive the great gravity. So you're done once you reach the event horizon. There isn't any way out. Even if you're still alive, you'd have to travel faster than the speed of light to get away. One of the many unsolved concerns surrounding black holes is whether or not dark matter exists. However, in order to validate Hawking's theory, scientists will require a large telescope that can see beyond current capabilities. This is where the almost $10 billion James Webb Space Telescope enters the picture. The entire scientific community held their breath as the JWST was ultimately launched into space from French Guiana. Intense vibrations during the launch may have caused damage and brought the operations to a halt. Because it was so large, engineers had to fold it several times to fit it into the launch rocket. The folding of the gold-plated hexagonal reflecting mirror is required. The 6-meter structure would not have fit inside any contemporary rocket, and the heat shield would have had to be folded in as well. It contains 5 layers that must be perfectly aligned in order to function. Each of these tennis court-sized layers is made of a different materials. The shield keeps it at the extremely low temperature required for infrared equipment. The JWST is still on its way to its eventual destination, the second Lagrange point, or L2, which is around 1 million miles away, where it will perch and look back billions of years in the history of the universe. L2 orbit is perfect because it keeps the telescope pointing away from the sun at all times, effectively shielding it from the star's heat and light. The telescope gathering area is quite vast. It is impossible to send astronauts to this location for repair because it is so far away. So NASA just has one shot at getting it right, or billions of dollars will be wasted. They'll be squandered. The launch crew, however, has received confirmations that the shield has successfully deployed, and engineers have begun the process of aligning the colossal golden mirror as part of the process. These individual reflectors will be integrated into a single focusing device. The observatory team will continue to reposition the mirror components away from their launch alignment, with more precise work following. NASA forecasts that the synchronizations will take roughly 3 months, with the project expected to be completed in mid-April if all goes as planned. It was thought that if the JWST's fuel ran out, it would endure for around 10 years. Following the success launch, NASA amended their estimate, suggesting that the JWST may have enough fuel for 20 years of science. The James Webb Telescope will thereafter shut down and remain in orbit. But first, the JWST will attempt to verify Hawking's contentious dark matter hypothesis. But what exactly is dark matter? As the name implies, dark matter is something that scientists cannot see since it doesn't emit light or energy. Because you can't see dark matter, you won't even notice it if you're near it. Scientists, on the other hand, are convinced that it exists. Indeed, they argue that dark matter accounts for roughly 80% of the universe's mass that is merely floats around like a huge material, influencing the gravity within galaxies. It's tempting to think that black holes are responsible for this enigmatic crap, because as previously established, black holes are dark. Populating a galaxy with black holes might hypothetically explain all dark matter discoveries. However, there's a flaw in their argument. In the current cosmos, black holes form only after enormous stars die and collapse under their weight of their own gravity. As a result, producing black holes necessitates both a big number of stars and a huge amount of ordinary material. Scientists have determined how much ordinary stuff there is in the universe based on the estimates of the early beginning, where the initial hydrogen and helium were generated, and it is simply insufficient to produce all of the dark matter detected by astronomers. On the other hand, Hawking came up with his own thought to resolve the problem. He's the one who suggested in 1971 that black holes created in the stressed environment of the Big Bang's early moment could spontaneously acquire the densities required to become black holes, overwhelming the cosmos with them long before the first star twinkled. Hawking hypothesized that dark matter exists. These primordial black holes have the potential to produce. While the hypothesis was interesting, most astrophysicists were more preoccupied with identifying a new subatomic particle that could adequately explain dark matter. Hawking's theory had weaknesses, and models for the formations of primordial black holes encountered observational hurdles. The idea only worked when the quantity and size of ancient black holes are minimal, otherwise it contradicts observations of the cosmic microwave background. If too many form in the early universe, they alter the picture of the cosmic microwave background, which is leftover radiations from the early universe. Scientists returned to Hawking's idea when the Laser Interferometer Gravitational Wave Observatory identified the first pair of merging black holes in 2015. The two black holes were far larger than expected, and one possible explanation was that they formed in the early universe rather than in the dying heart of a dying star. In their research, Priyamvada Natarajan of the University of Miami and Gunther Passinger of the European Space Agency expanded on the hypothesis of primordial black holes, looking at how they can explain dark matter and address other cosmological difficulties. To pass current observational testing, primordial black holes must be within a specified mass range. The researchers created a model of the cosmos, substituting all black matter with these comparatively light black holes, and then looked for observable signals to confirm or contradict the model, such as the primordial black hole's mass being around 1.4 times that of the Sun. The scientists found that primordial black holes seeded the earliest stars, galaxies, and supermassive black holes, which may have played a crucial role in the origin of the universe. Their findings imply that stars, galaxies, and superlarge black holes appeared very quickly in cosmic history, possibly too soon to be explained by the current universe's birth and expansion processes. The next generations of gravitational wave detectors, particularly the Laser Interferometer Space Antenna, or LISA, will reveal a great deal more about black holes, even primordial ones, if they exist. When the two observatories are merged, they should provide astronomers with enough data to piece together the story of the first stars, and maybe the origin of dark matter. Do you think the James Webb Telescope will be able to confirm the black hole theory? Or do you believe it will not last long enough to fulfill its promises? That's all there was to it. Thank you for taking the time to listen to this. If you enjoyed it, please spread the word and subscribe to our channel for more great videos and up-to-date information. We hope to see you in more videos in the future.